In this video, we're going to talk about calculating volume and concentration of solutions using two key equations and looking at some exam-style questions. The two equations we're going to use are to do with solids, which is our equation here, and to do with solutions here. And we're going to combine the two. The reason we can combine the two is because moles appears in mass over relative molecular mass or relative atomic mass, and moles also appears in volume times concentration. So that means you can connect the two together, for example, using a mass to calculate number of moles, and then you can use that to calculate the relative concentration you'll get if you know your volume. But we'll go through examples of that in the video. So the first question we've got is how to make a standard solution. So describe how to produce 250 centimeters cubed of 2.5 mole per decimeter sodium hydroxide. Now the first thing you need to know is that this equation, number of moles equals volume times concentration, is used to make solutions, and the unit is decimeters. That is not decimeters, so you need to convert. So our conversions are down here. Okay, and we need to do decimeters to centimeters cubed at times, and we need to do centimeters cubed to decimeters at times. So if we're going from a decimeter to a centimeter, it's a difference of 1,000, so you times by 1,000. If you're going from centimeters cubed to a decimeter, it's divide by 1,000, and we'll keep that conversion there all the way through. So first of all, if I'm going to do this, I need to convert this centimeters cubed to decimeters so that the unit matches in that equation. But let's put this over to the side now. Okay. Now I've highlighted the 250 and the 2.5 because that's what we have to use, the volume and the concentration. Okay, so what we have to first of all do is do our number of moles, which is N. Okay, and we have to take our volume, which is 250 centimeters cubed, divide that by 1,000. So 250 divided by 1,000. You can put it like that if you want. Okay, and then we have to times that by our concentration, which is 2.5. Okay, so we have got our centimeters cubed here being converted into decimeters, and we've got our moles per decimeter cubed here. Okay, now when you do that, that will equal 0.625, and that will be in moles. So now you've got your number of moles that you need, okay? But the question is saying, how do you produce it? How do you do that? Well, physically, you've got to know how much, in terms of mass, of your sodium hydroxide you add to your 250 centimeters cubed of water. So we need to use the rearranged equation from the first slide, which says mass equals moles times MR. So we've rearranged this, and you need to get used to rearranging equations. The equation is normally moles equals mass over MR. So we've just rearranged that to give it some mass is the product. So from that point, we take our 0.625 moles, and we will say, right, let's calculate the mass from now on. So the mass, okay, is going to be equal to our number of moles, which is 0.625. And then we will times that by our MR. Now, if you calculate this, hopefully you've got a periodic table by you and you're calculating that. The molecular mass is 40, and that's 40 grams per mole. And if you put that all into calculator, you will find that that is 25 grams. Okay, so we have 25 grams. And that means if we're going to make this and describe how to make it, that means we have to put 25 grams of sodium hydroxide in 250 centimeters cubed of water. Okay, so that is how you make a 250 centimeter cubed of a 2.5 moles per decimeter cube solution of sodium hydroxide. Our next example is about making a new concentration from a solution of a different concentration. So we have a student with 5 centimeters cubed of 1 times 10 to the minus 4 moles per decimeter cubed, and we need to convert that into 2.5 times 10 to the minus 6. And we need to know how much water we add to do that. Now this involves number of moles equals volume times concentration only, and you have to rearrange this. So if we put this over the side, and then we rearrange this equation, you can see that we've got moles equals volume times concentration, and then we've rearranged it down here, and we said volume is therefore equal to number of moles. We pull the volume, the concentration down. So we pulled that concentration down, and now we're dividing by it. So that means volume equals number of moles divided by concentration. So just the same equation rearranged. Then what we do is we work out our number of moles. So our number of moles is going to be equal to our volume that we have at the start. So we have a volume at the start. And I told you last time to divide by 1,000, as I've got down here, to turn it into decimeters. Now I want to show you a slightly easier way. In your calculator, there is an EXP button, or it's also called times 10 to the x. If you press that button and then put -3 in there, it will automatically divide by 1,000. So I can even express that in this equation. So I can do 5 from over there, there's my volume, and then just put 5 times 10 to the -3. That automatically converts it into decimeters. Then I will times that by the concentration that I have, which is 1 times 10 to the -4. So we've done a volume times a concentration. And then from there, we are going to make our number of moles, and our number of moles will be 5 times 10 to the -7. Again, that's just me putting it into the calculator. So we now know our number of moles that we had in our original solution. Okay, and we need to know what volume we need to change it so we get the new concentration. So we know the new concentration, we know the number of moles we have. So we need to know the volume that we add to make that happen. So what we can then do is go, right, okay, our volume measurement is going to be our volume here. Okay, and that is going to be equal, and it's really important here, that is in decimeters. Okay, so it's in decimeters. And you do your number of moles. Your number of moles is 5 times 10 to the -7. Okay, then that's divided by your concentration. The new concentration, though, which is 2.5 times 10 to the -6. Okay. Okay, and that's your number of moles divided by your concentration, which will then be equal to, okay, and it's equal to 0.2 decimeters. Again, I'm focusing on the decimeters. What volume of water is added? Now, normally what they say is they will say what unit. So we're going to say, well, what unit is it here? Well, the unit's going to be centimeters cubed. So I want to find out what it is in centimeters cubed. Make sure you really look carefully at the question on the units of what you're expected to do. So I want this in centimeters cubed. I don't want it in decimeters. So that means it's not 0.2 decimeters cubed. This is actually going to be 200 centimeters cubed to start off with. So I want a 200 centimeters cubed solution. So most people would make that mistake, and it is a mistake to say straight away 200 centimeters cubed. Now, why is it a mistake? It's a mistake because the question says what volume of water is added. You already have 5 centimeters cubed, and it is asking you what is added. So therefore, if I want to know what is added, I need to find out what I've already got and take that away from the total volume I know I need. Now, that means it's 200 centimeters cubed minus the 5 centimeters cubed we already have. So our final answer is going to be 195 centimeters cubed. So I have to add 195 centimeters cubed to make that solution. So 195 to 5 centimeters cubed is my answer. We're now going to do our final question of converting moles per decimeter cubed to grams per decimeter cubed. So essentially using the grams that is applicable to the number of moles. So we're going to convert moles per decimeter cubed to gram per decimeter cubed, and our question is you have 50 centimeters cubed of a 2.5 moles per decimeter cubed solution of sodium hydroxide. Just change the units into grams per decimeter cubed. And this will often be tagged on the end of a question, so you have to work out the concentration, then it will ask you to put it in grams per decimeter cubed instead of moles per decimeter cubed. So let's move that again over to the right. Okay, and we've got our equation that we've been using throughout this video. Moles equals volume times concentration. We're going to have to find out the number of moles, and then after we found out the number of moles, we have to convert that into grams. And grams being a mass measurement, we use this equation where you've got mass equals moles times mR, which again we've used earlier in the video. So if you look over at our question, you can see that we've got 50 centimeters cubed and 2.5 mole per decimeter cubed concentration. So we need to convert that into decimeters. Okay, and there we go. And we have that in decimeters, so that's 0.05. Remember, you can do that by just doing 50 times 10 to the minus 3 in your calculator if you want. And then you times that by the 2.5 moles per decimeter cubed to get 0.125. Now you know your number of moles, so which means you know this number here. Okay, and you know the MR because you're told it's sodium hydroxide. So you're told it's sodium hydroxide, so working out the MR is 40. So we do 0.125 times 40, which will equal 5 grams. So if I want to make this solution, I have to add 5 grams to a decimeter of water, and therefore the concentration is 5 grams per decimeter.